With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, consider the two statements related to circular motion in usual notation. Okay, so let's see the solution. So actually for this question we have given here the two statement, and we have to state that which of the statement is true and false. Okay, so for that let's see the first statement, that is A. In uniform circular motion, omega, velocity v and the acceleration are always perpendicular. Okay, so for this let us assume the example, that is, let a particle doing a uniform circular motion with velocity of v, okay, which will be tangential to this circular motion. Right, now in uniform circular motion there will be only one acceleration which will be toward the center of circular motion, and that can be denoted as centripetal acceleration, AC. Now if we see here, so at any instant this velocity will be tangential and this centripetal acceleration will be towards the center, right? So here I can say that these velocity and the acceleration both are the perpendicular to each other. Okay, so in uniform circular motion, velocity and acceleration are perpendicular to each other. This we have seen here, right? Now what is the remaining, that is omega. So actually omega is given by d theta by dt. Now as the angle will change, so obviously the value of the omega will also going to be changed, right? But we know that the direction of omega is given by, that is, this will be in z direction, okay, and as the z is perpendicular to xy plane, so ultimately this omega will become perpendicular to acceleration and velocity. Okay, so here I can say that in uniform circular motion, acceleration, velocity are perpendicular to omega, right? So according to this, statement A will become correct. Now let's see the statement B, that is, in non-uniform circular motion, omega, velocity and the acceleration are always mutually perpendicular. Okay, so in second statement it is actually talking about non-uniform circular motion. So let's suppose a particle doing a non-uniform circular motion, so with a velocity of v, which will be tangential to this circular motion like this, and let's suppose the radius of the circle is, means this circular motion is small r. Now in non-uniform circular motion there will be two types of acceleration. One will be toward the center of the circle, okay, and another will be tangential to this circular motion. Okay, so actually this acceleration is tangential acceleration, and the acceleration which is toward the center is centripetal acceleration. Okay, so if you try to find the net acceleration for this, so this net acceleration will be at an angle of theta with respect to the velocity. Okay, so here if we draw this, so we can see that is this velocity vector means the acceleration, net acceleration is inclined at an angle of theta with respect to the velocity vector in non-uniform circular motion. So obviously it won't be perpendicular to the velocity, right? So here I can state that the acceleration is not perpendicular to velocity vector in non-uniform circular motion. Now what will be about the omega? So actually, as we have stated above, the omega going to be changed as the angle will change, and as we know that the direction of omega is in z direction like this. Okay, so obviously as this z axis is perpendicular to xy plane, so ultimately this omega will get perpendicular to this acceleration and velocity, right? So in non-uniform circular motion, I can say that the omega will be perpendicular to acceleration or velocity, but acceleration won't be perpendicular to velocity vector, right? So according to this, statement B will become wrong. So if we look to the options, so option third, that is A is true but B is false, become correct answer for this question. So this is the required solution. I hope you like this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.